This is part 2 of the quantity check for lab 5. So now for reaction 2, we have to find how much sulfuric acid we need to add for reaction 2. So when you go to lab flow, we are now in question 4, and it says the amount in milliliters of 9 molar sulfuric acid we need for reaction 2. So again, we are going to be using stoichiometry. And the only information given is the 1.25 grams of the solid aluminum and 9 molar sulfuric acid. So the first thing we're going to do is start with the 1.25 grams of aluminum using stoichiometry. So we have 1.25 grams of aluminum. We're going to multiply by 1 mole of aluminum and divide by the molecular weight, which is 26.98 grams. But to get from aluminum to sulfuric acid, that does not show in reaction 2, but in reaction 1. Because in reaction 1 right here, we're going from aluminum to aluminum hydroxide 4-. And then you see in reaction 2, we're going to go from aluminum hydroxide 4- to H2SO4. So first we have to use information from the balance equation from reaction 1, and then go to reaction 2. So there is 2 moles of aluminum, and then 2 moles of aluminum hydroxide 4-. And this is from reaction 1. Now we can use the balanced equation for reaction 2. So 2 moles of aluminum hydroxide 4-, and there's 1 mole of sulfuric acid. And what answer do you get there? You should get 0.023165 moles of H2SO4, which is the sulfuric acid. But remember, the question asks for milliliters. So now we can convert from moles to milliliters using the molarity. Because remember, molarity, which is concentration, is moles per liter. And it was given that the concentration is 9 molar. So, take the answer we just calculated, and you're going to divide by 9 moles, because that is the concentration, because remember, molarity is moles per liter, but we have to flip it so that way moles cancels out and we get liters. So the answer we should get there is 0.00253 liters. But our answer has to be in milliliters, so we just will multiply by 1,000 to get milliliters. 0.02573 liters. I'm going to multiply it by 1,000 milliliters, because for every 1,000 milliliters there is 1 liter. Liters cancels out, and the answer we should get is 2.57 milliliters of 9 molar sulfuric acid for reaction 2. So that value goes for number 4 right here. And we're going to do the same calculation for number 5. So when you go to the PowerPoint, it asks, what is the second amount of 9 molar sulfuric acid that we will add for reaction 3? And again, the answer will be in milliliters. So again, the same information is given. 1.25 grams of aluminum and 9 molar sulfuric acid. Again, we're going to use stoichiometry to get the milliliters of sulfuric acid. So we're going to start out with the 1.25 grams. For every 1 mole of aluminum, the molecular weight is 26.98 grams. And remember, we have to use the balanced equation from reaction 1, because we're going from aluminum to aluminum hydroxide 4-. And then here we're going to be using the balanced equation from reaction 2, because we're going to go from aluminum hydroxide 4- to aluminum hydroxide 3. That way, when we go to reaction 3, we have aluminum hydroxide 3, and we can go to sulfuric acid here. So we're going to multiply by 2 moles of aluminum hydroxide 3. And divide by 2 moles of aluminum hydroxide 4-. So this is from equation 1. This is from equation 2. And now to equation 3. In the numerator, it's going to be 3 moles of H2SO4 and divide by 2 moles of aluminum hydroxide 3. And this is from balanced equation 3. So when you go through, moles of aluminum cancels out, grams cancels out, this will cancel out, and then you're just left with moles of sulfuric acid. So when you do that, the answer you should get is 0.06949 moles of the sulfuric acid, which is H2SO4. And then remember, we need milliliters, so you're going to multiply by the molarity or the concentration, which is 9 molar. 0.06949 moles, and molarity is 9 moles per liter. Moles will cancel out, and you get 0.00772 liters. But remember, we need milliliters, so you're going to multiply by 1,000 milliliters, because for every 1,000 milliliters there is 1 liter. The answer you should get here is 7.72 milliliters of 9 molar sulfuric acid. That will be added for reaction 3. So 2 new values that you need to have in your proposal are, so proposal values. So for reaction 2, you're going to add in 2.57 milliliters of 9 molar sulfuric acid. And then reaction 3, you're going to add in 7.72 milliliters of 9 molar sulfuric acid. And I should see these values in your proposal. Okay? If you have any questions, you can always email me.